So in this video, I'm going to try to explain transformations. This is the problem that's on the back of the homework on the top left, where you have a graph and you're supposed to label the points and perform some sort of transformation. Transformation is a general term for any movement of a point or a shape on the coordinate grid. Now I'm going to slide this over. So first things first, the coordinate grid looks something like this. Usually it's all boxed in with little checkers everywhere, right? Little squares everywhere. So any point on here is a combination of an x and a y. So the first number is always an x, then there's a comma, then the second number is a y. And what that means is, well, first of all, you start here, which is 0, 0. It's called the origin. You always start there. The x is this x-axis. So the first number tells you whether or not to go right or left. If it's a positive number, like 2, you'd go over 2. If it's a negative number, you'd go over negative 2, like that. Then the y tells you to go up or down. If it's a positive 2, for instance, you would go up to this point. If it was a negative 2, you would go down. So positive 2, 2. This would be positive, negative. This would be negative, positive. And this is negative, negative, right? So the idea is all of these points would be 2, 2 in some way, but everything in this quadrant is positive, positive. So if it was positive 2, it would be there. If it was negative 2, positive 2, you'd go negative 2, positive 2 would be there. If it was negative, negative, you'd go back here, then down to there. And if it was positive negative, you go over here, but then go down instead of up, and it would be there. So that's the way the coordinate grid works in general. So with that in mind, we're going to look back at your process chart on the left here, and then just give some examples of what this means. So let me move this back over. Now, I know this is very small on the screen, but you can also print out this page and follow along, and I think then it'll be easy to understand what's going on. So translations means to slide the figure. So if you had a figure like this, you would slide it back and forth or up and down. There's no like rotating or flipping or anything like that. So it says, for instance, right, which is to the east, you add to the x. So if you had 2, 3, and you're going to the right 2 spaces, so to the right means add to the x. So you take your 2 and you would erase it, or rewrite it in the new place, and it would be 4 because you added 2 to it. Okay, so all the translations are like that. To the right or to the left, you're changing your x. They're adding or subtracting. If you're going up or down, you're changing your y. You're going up or down, adding or subtracting to that. Translations are very easy. Most kids can do them. The next one is reflections. That is like this. You have something like this and it flips over like that. That would be flipping over the y-axis. Or it's something like this and it flips down, which means it's flipping over the x-axis. But what happens to the coordinates? Well, for instance, it says there's an opposite relationship. If you're going over the x, you're changing the sign of the y only. If you're changing over the y, you're changing the sign of the x only. So if your original point is point A, and we called it, say it was 2, -1, if you're reflecting over the x, then the sign of the y changes. The 2 stays exactly the same. By the way, this would be A prime. The 2 stays the same. The -1 becomes a +1. That's it. That's a reflection over the x-axis. Now, however, if you were going to reflect over the y, you would do, again, it still would be called A prime. That just is after you move a point. Now, to reflect over the y, we're going to change the sign of the x. It was +2. It becomes -2. Okay, that's it. It's really simple. It doesn't involve very much thought. You just have to change the sign. And it's an opposite relationship, x and the y. Okay, the rotations are a little bit more difficult. Let's see how much time, 4:50. So I'm going to make another video about the rotations after this one.